Hi, Mr. Machado. This is my chemistry ISP presentation. The one that I chose is angelic acid. So let's get started. So what is angelic acid? So the origin. So it was actually discovered by German pharmacist Ludwig Andreas Buchner in 1842. And what he did is that he isolated it from the roots of Angelica archangelica, which is more commonly known as garden angelica. And here's a photo right here of it. And the angelic acid is usually found in the Apiaceae family. And the acid itself is called angelic, even though it's far from that, because the name was derived from the plant that it was isolated from. So the structure of angelic acid. So the molecular formula of the acid is C5H8O2, and there's a carboxyl group, so that's the COOH, and there's also a methyl group. And angelic acid has high melting and boiling points. The melting point is actually 45 degrees Celsius, and the boiling point is 185 degrees Celsius. And from this, you can infer that the intermolecular forces between the atoms are very strong, and that it's likely that they are polar covalent bonds. And because there is a carboxyl group present, you can infer that there are also hydrogen bonds present in the structure of angelic acid. So next is the IUPAC name. So IUPAC stands for International Union of Pure and Applied Chemistry, and the IUPAC name of angelic acid is Z2-methyl-2-butanoic acid. So how I structured it, I broke it up into 4 parts. So starting off with the Z, there's a system called the EZ system, and it basically names the cis and trans isomers of a certain compound. So angelic acid is actually the Z isomer of 2-methyl-2-butanoic acid, the cis isomer of it. And what this means is that the higher priority groups at the ends of the double bonds are on the same side, whereas the trans isomer, the E isomer of 2-methyl-2-butanoic acid, it's called tiglic acid, and for that one, the higher priority groups, so the methyl, these ones, the methyl groups, are on the opposite side of the double bonds. And so the Z and the E distinguish those two acids from each other. The next part is the 2-methyl. So there's a methyl group on the 2-carbon, as you can see here. The but part, so the prefix butane, so there's 4 carbons in the parent chain, and there's a double bond on the 2 carbon, so that's indicated by the 2-butanoic acid. And because angelic acid is a carboxylic acid, it's named a little bit differently. So all carboxylic acid have the oic acid suffix, and the E is there because there's a carbon-carbon double bond. So angelic acid is also a little bit more unique, and it has the E part as well. So what's angelic acid used for? So to start off, we're gonna go over the Wemyss things. So angelic acid is corrosive to metals, and this is the label that you would usually find on the container, and it can also cause serious eye damage. So the safety handling precautions that you would have to take if you were to handle this substance, you have to make sure that it's stored in the sealed container, the correct labels, it's not broken or damaged in any way, and it's preferred to not even preferred, like you can't be reusing containers and putting angelic acid in a container that doesn't belong to it, because reactions may occur. You must also store angelic acid away from other materials, especially incompatible materials such as bases, because acids and bases react violently with each other. You have to also thoroughly wash your hands before and after handling the angelic acid, because if there's any residue, you might touch your face, you might touch other things, and it might cause damage to you or others. Additionally, when you're storing angelic acid, it has to be in a cool, well-ventilated area, and you must also make sure that there's cleaning supplies in case there's any spill that might happen, so you can react as quickly as possible. Next are the reactions to form angelic acid. So as I mentioned earlier, tiglic and angelic acid are cis and trans isomers of 2-methyl-2-butanoic acid. And basically, you can actually make tiglic acid from angelic acid and vice versa. So, and that's what we're going to do. So to make angelic acid from tiglic acid, it's a 3-step process. So the first one, combine tiglic acid and bromine, and you get beta-dibromo alpha methylbutyric acid. Next, you get the product from the first step, and you add methanolic potassium hydroxide, and you get beta-bromoangelic acid. And in the third step, if you reduce the product from the second step, which is beta-bromoangelic acid, with sodium amalgam in water, you get angelic acid, and it's about an 85% yield, which is pretty high compared to other forms of getting angelic acid. Next are the uses. So it was formerly used as sedatives, and it's also used, and now it's used as a herbal remedy for minor health-related problems such as fever, heartburns, and headaches. And here's a sample of a sedative. And that is the end. Thank you for listening. But there are also some works cited, and I'll just leave it for a second. And this is the second one. And that's it. Thank you.